Today we will learn about the numerical differentiation. So you know that this f prime x means the df dx means the differentiation, the gradient or slope, and also the rate of change. So before this, you have learned to find the exact solution of the differentiation. So that is the analytical method where you use the product rule, quotient rule, power rule, and also chain rule in order to find the exact solution of the differentiation. So now we will find the differentiation using the numerical method. In this case, we will use the finite difference formula. So numerical differentiation is used to find the approximate solution of the derivative, the slope, or the rate of change for the function fx at any particular point. So look at this graph. So now let's learn about the first derivative, f prime x. This curve is the fx curve. For first derivative, we can use the 2 points forward difference, 2 points backward difference, and the 2 points central difference. So this is point A, point B, and point C. Okay, in 2 points forward difference, you will use this point B and C. Okay, the formula will be fxi plus 1 minus fxi divided by xi plus 1 minus xi. Xi plus 1 minus xi is equal to h. Okay, this is value h. For 2 points backward difference, you will use the slope of the line that connects point A and B. This is A, this is B. So it will be this line. Okay, the formula will be fxi minus fxi minus 1 divided by xi minus 1. Xi minus 1. This is also equal to h. And the 2 point center difference is the slope of the line that connects point A and C. It will be this line A and C. So the formula will be fxi plus 1 minus fxi minus 1 divided by xi plus 1 minus xi minus 1. So this minus this, you will get 2h. So it will be 2h here. So this is the formula for first derivative. So we can use the following difference formulas to compute the various derivative. 2 point forward, 2 point backward, 2 point central. Okay, so 2 point forward, this is your xi. This is your xi plus 1. 2 points backward, this is your xi, and you will use point xi and xi minus 1. Okay, 2 points central, this is the value that you want to find, xi. So you will use this value xi plus 1 and xi minus 1 to get this xi. For 3 point forward, okay, you will use 3 points, xi plus 1 and xi plus 2 divided by 2h. Okay, 1h, 2h. 3 point backward, xi minus 1 and xi minus 2. And for 4 point central, you want to find this xi. So you will use these 4 points. Okay, xi plus 2, xi plus 1, xi minus 1 and xi minus 2. So you just follow this formula, then you can find the finite difference 4 point central. Now look at example 1. Let fx equal to x squared by using forward, backward, and central difference formula and data points x0, y0, x1, y1, x2, y2. Okay, estimate f prime x1 or f prime 1 with h equal to 0.5. And then compare which formula will produce the best result. Okay, from the data given, write it in the table form. This is your x and this is your fx. So this is your xi. Xi is the value that we want to find. Given here, 1. This is the value that you want to find. Just follow the formula. So this will be your xi. This will be your xi plus 1. And this is your xi minus 1. This is your fxi. This is your fxi plus 1. And this is your fxi minus 1. So first, using the forward difference formula, fxi plus 1, 2.25. 2.25 minus fxi minus 1. Divide by xi plus 1. 1.5 minus xi minus 1. Okay, simplify, then you will get 2.5. Similarly, for backward difference formula, you will use this value and also this value. Substitute correctly into the formula, then you will get 1.5. And for central difference formula, you will use these values and these values, then you will get 2. Question number 2, compare which formula will produce the best result. You have to find the exact value and compare. This is your fx. Differentiate this analytically, you will get 2x. Substitute x with 1, we get 2. So just compare with the numerical differentiation just now. It is obviously shows that the central difference formula give the best answer. Okay, 2 equal to 2. So this is the formula for second derivative, f double prime. And for third derivative, f triple prime x. Okay, and also for fourth derivative. Okay, now let's discuss this exercise. So here I have underlined some of the important points. Okay, look at question number 1. Calculate the first derivative of the function fx at point x equal to 5 numerically with the forward, backward and central finite difference by using x equal to 4, x equal to 5 and x equal to 6. And another points, x equal to 4.75, x equal to 5 and x equal to 5.25. So in this case, this is your xi, the value that we want to find. Okay, then compare the result with the exact derivative in terms of percentage value. Okay, let's look at the answer. So this is your f prime x. This is your fx. When you differentiate it one time, you will get this 9x squared plus 4x plus 1. So when x equal to 5, just substitute x equal to 5. Then you will get f prime 5 is equal to 2, 4, 6. So this is the analytical differentiation. Okay, so now let's find the numerical differentiation. Okay, the equation asks you to find the forward, backward and central finite difference. Just substitute all this value. This is your xi, xi plus 1, xi minus 1. And this is your fxi, fxi plus 1, fxi minus 1. Okay, substitute into the formula correctly. Then you will get the answer for forward finite difference 296, backward finite difference 202, and central finite difference 249. Then you have to find the percentage error. This is the formula for error. Numerical value 296 minus the exact value 246 divided by the exact value 246 times 100. Percentage error will be 20.33%. For backward finite difference 17.89%. And for central finite difference, the percentage error is 1.22%. To determine the best result, the percentage error between the exact solution and approximate solution must be nearest to 0. So from the calculation here, where 3 formulas were used, the finite central formula has the best result because the percentage error is the lowest. Question number 2. Okay, so this is your xi plus 1, xi minus 1, fxi plus 1, fxi minus 1. Substitute the values into the formula, then you will get this answer. And then find the percentage error for forward finite difference 4.85%, backward finite difference 4.70%, and for central finite difference 0.08%. Okay, again the results show that the central finite difference formula give a more accurate approximation. Okay, in addition, the smaller step size h give a significantly more accurate approximation. Okay, now look at question number 2. Calculate the third derivative for the function fx equal to negative 1 over 2x cubed at point x equal to 2. So this is your xi. Numerically with the 4-point central finite difference formula. Okay, by using these values of x, okay, then find the percentage error of the result. So remember, before you find the percentage error, you need to find the analytical differentiation. Okay, let's look at the solution for question number 2. So this is your fx. Simplify this, become this. Then differentiate it one time, f prime x, f double prime x, and f triple prime x. Okay, and then substitute x equal to 2, x I equal to 2. Substitute 2, then your f triple prime 2 is equal to 0.46875. And then this is the 5 points given in the question. So from the given points x, you can find your fx by substituting all these values of x into your fx. Okay, then the question asks you to find the 4-point central. Okay, substitute all these values into this formula correctly and then simplify. Then you will get 0.5552. So this is your numerical solution and this is your analytical solution. Okay, now let's find the error. Numerical differentiation minus analytical divided by analytical solution times 100. Then you will get 18.4%. That's all for today. Thank you.